Alright, so this is the absolute value problem. So the first thing I'm going to do is isolate my absolute value. That's what I always do. I say I have to get the absolute value all by itself on one side of the equation. So, all I'm going to do is add 1 to both sides of the equation. So when I do that, let's go and I'm going to, I'm sorry, subtract 1 from both sides. And that's going to leave me with the absolute value of 2x plus 1 is less than or equal to 4. All right, now that I've done that, I can go ahead and split this. So Claire, I'm actually going to just set it up as an equality, and then I'm going to check points because I think that's easier. So in this case here, there's other ways to do it, but if I'm just doing this, to pass a test, I'm just going to check points. So in this case here, I'm going to split this. So the next step here is to split it like an equality, okay? So I'm going to say the absolute. I don't want to do that. Go. I want to say 2x plus 1 is equal to 4, or 2x plus 1 is equal to negative 4. And I'm just going to solve both these. So I'm going to subtract 1 from both sides, and I get 2x is equal to 3. Therefore, x is equal to 3 halves. And then over here, I'm subtracting 1 from both sides, and I get 2x is equal to negative 5. Therefore, x is equal to negative 5 halves. All right, so now all I'm going to do is to check points. I know that something special happens here, right? And I know that something special happens here. And in this case, right, I know that it can equal. So let me move on to, remember, so we had the absolute value of 2x plus 1 plus 1 is less than or equal to 5. And we got, x was equal to 3 halves, or x was equal to negative 5 halves. Okay, remember that's what we got on the other screen. So in this case, I'm just going to draw my number line. Why is it doing this? There's my number line. And here's 0, right? And I'm going to say here's negative 5 halves. And here's 3 halves. So I know that that's a solid dot because those are where they're equal to one another, right? And then I'm going to try 0. And if I plug 0 in, I get the absolute value of 2 times 0 plus 1 plus 1 is less than or equal to 5. So this gives me, 1 plus 1 is less than or equal to 5. Therefore, I get 2 is less than or equal to 5. And that's true. So I know 0 is a solution. So this has to be a solution. So I know that it has to go like, my graph has to go like this, So if I was putting it in set notation, right, it goes from, negative 5 halves to 3 halves inclusive. All right? So that was pretty straightforward. So once again, all we did was, first thing we did was to isolate the absolute value. Second thing we did was to make it an equality. We split it, we set it equal to, right, positive 5, and then the other side was equal to, we moved it and we set it equal to, this became a 4 because we subtracted 1, so it was equal to 4, negative 4. That gave us these two solutions. We graphed those two solutions. It had to be equal because this was equal, and I chose a point in the middle. Because when I chose 0, I got a true statement. I knew 0 was part of the solution, So I had to graph to include 0. If it was false, right, then, you know, my graph would have gone this direction and that direction instead. Alright, that's the end of that one.
I knew that!
Alright, so this is just, you know, like a boring problem. So the first thing I look to is, can I possibly factor this? And the answer is no, I can't, because, you know, there's nothing that's going to, you know, multiply to give me 1 and then add to give me 4. So there's nothing I can do. So now, you know, I'm just going to use the quadratic formula, which says, you know, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, you know, all over 2a. That's just such a pretty all over, huh? All right, kind of went all over the place. All right, so in this case here, you know, my b is equal to 4, my a is equal to 1, and my c is equal to 1. So, you know, the coefficient on x squared is a, the coefficient on my x term is b, and the constant is c. So I just plug them in, and away I go, and I get x is equal to negative 4 plus or minus the square root of, you know, 4 squared minus 4 times 1 times 1 all over 2 times 1, and that's going to give me negative 4 plus or minus the square root of, well, 16 minus 4 is 12 over 2. So this gives me negative 4 plus or minus 2 radical 3 over 2. And because 12 is 2 radical 3, right? So yeah, let's just go up here and just really quickly. The square root of 12, right, is equal to the square root of 4 times 3. Well, the square root of 4 is 2, and I'm left with that radical 3 under there. Okay, so now I can go ahead and take a 2 out of every single term. That's the key. It has to come out of every single term. So this here, right, this is equal to, that's an equal sign, negative 2 plus or minus radical 3 over 1. So there you go. And that's my final answer. Okay? Alright, so that finishes that one. Let's send this one.